I'm just going to get my charger 1 second. Okay, so we're going to go through some definitions. A blank is a A blank is a curved path between 2 points on a circle. This blank is arc. An arc is a curved path between 2 points on a circle. So here, let's say I have circle O, and then I have the path between A and B. That path between points A and B, that's called an arc. A central angle is an angle whose vertex is at the center of a circle. So let's say I have angle AOB. Because O is the center of the circle and O is the vertex of my angle, this is called a central angle. And a central angle always intercepts a minor arc. And we'll talk about minor versus major in a minute. But a central angle always intercepts a minor arc. All right, a minor arc is an arc whose points are on or between the sides of a central angle. So here, I don't know if you guys see it or if it got cut off for you. We have central angle AOB, and it intercepts an arc. It intercepts arc AB. That arc AB, that is our minor arc. And the way you write a minor arc, the symbol for it is you draw an arc, and then underneath of it, you write the endpoints of the arc. So we go from point A to point B, or point B to point A, it doesn't matter. So this could be arc AB or arc BA. The order of the letters does not matter. All right, a blank is an arc whose points are on or outside of a central angle. This is a major arc. A major arc is an arc whose points are on or outside of a central angle. And what does that mean? Well, do you see how there's a path from point A to point B? All right, so the short path from point A to point B is the minor arc. But isn't there a longer path from point A to point B also? The longer path from point A to point B, that's called the major arc. Now, how do we distinguish between a minor arc and a major arc? The way you distinguish between them is there needs to be a third point. So if I'm taking the path from A, the long way to B, we need a third point. Let's call this X. So this is saying go from A to X to B. Take the long way around. And the way we write that is you draw an arc symbol, and then you're going to write the 3 letters. The 2 endpoints have to be the last letters. So I'm going to say A first, then X, then B. So this is sort of telling you, take the path from A to X to B. You could have done B, X, A, saying take the path from B to X to A. It's the same as long as the endpoints are the first and last letter. A semicircle is an arc whose endpoints are at the endpoints of a diameter? Sorry?
So in order to have like a major arc, you have to have a point in between, right? Or else it would be...
Yeah, you could always add a point in between because
okay.
there's an infinite amount of points there. So you could always write in your own if you want to address the major arc and there's no point there.
Okay.
All right, so a semicircle is an arc whose endpoints are the endpoints of a diameter. Who remembers back from, I don't know, elementary school, what does a diameter do to a circle? Robert? It cuts it in half, right? A diameter splits a circle in half. So if you take the path from one endpoint of the diameter to the other endpoint of the diameter, that is called a semicircle. How many semicircles does this triangle have? Just 0? No. A semicircle is not a triangle. Oh, I said triangle. I'm sorry. How many semicircles does this circle have? How many semicircles does this circle have that's drawn in? 2, yeah. Sorry. So now there's another semicircle this way. Any guesses on how many degrees a semicircle is? And why? How many degrees is a semicircle? I'm sorry? 180. How did you know that? Exactly. If you guys remember, a full circle is 360. So a semicircle, a half circle, has to be 180 degrees. Now, a semicircle can be written as a minor or major arc. It doesn't really matter. It can be written as a minor or major. It does not matter. All right, so we already spoke about this. The symbol is used to label arcs. The minor arc joining A and B is called arc AB. The major arc joining A and B is called arc AXB. And it's that extra point X that helps us distinguish between the minor and major arc. Okay, so just make sure we're pretty solid on definitions here. Let's give an example of. So they're saying circle C. It is really important here that they're telling us circle C. What does this identify for us? PJ? C is the center of the circle. There's no question about it. They told us circle C. We name a circle by its center, so C is the center. So based on the knowledge that C is the center of the circle, can somebody name me a radius? Or actually, name me 2 radii. Abby?
DC and CB.
You got it. DC and BC or CB. Is there another radius? Yeah, what's another radius? AC, you got it. And what do we know about all radii from previous knowledge? What do we know about all radii? They are congruent. All radii are congruent, so we'll keep that in mind also. Right, a diameter. Now remember, a diameter is a chord that goes through the center of the circle. So a diameter is a chord that goes through the center of the circle. So looking here, how many diameters do we have drawn in? Everybody show me with your fingers. 1, 2, 3, 4, 5. 1. Good. All right, we only have 1 diameter. What's the name of this diameter? DB. Hey, somebody name me a chord that is not a diameter, because a diameter is a chord, but somebody name me a chord that's not a diameter. Did we talk about chords yet? Did I tell you about chords? Yes. Okay, great. Liv? DE, you got it. All right, someone name me 2 different central angles. Casey? Perfect. Okay, remember, a central angle has to be an angle whose vertex is at the center. So here is one central angle, here is another central angle. All right, two minor arcs. Two minor arcs. So basically a minor arc is a path that's less than 180 degrees. That's a good way of looking at it. It's a path that's less than 180 degrees. Edwin? You got it. Arc AD and arc AB. All right, now what I want us to do is name those same arcs, but the long way around. I want to name them as major arcs. So the first one was arc AD. So how would I name this as a major arc? PJ? Perfect. Arc DBA. All we had to do is add a third point going the long way around. That's how we would make a minor arc into a major arc. Can somebody different, not PJ, tell me how would I make arc AB into a major arc? So this is the shorter path. Now how would I represent that same arc AB but now the long way around? Jack? You got it, ADB. All right, now let's name two semicircles. I'm going to name them with 3 letters because remember I told you we can name it as a minor arc or a major arc. I'm going to name it as a major arc. I'm going to say DAB is one semicircle, and the other semicircle is going to be DEB. So I named the semicircle on top, and I named the semicircle on the bottom. All right, let's keep going. All right, the measure of a minor arc or semicircle is the same as the measure of the central angle that intercepts the arc. The measure of a major arc is 360 degrees minus the measure of the minor arc with the same endpoints. Okay, so what is this saying? Basically, it's saying the degree of your minor arc and the degree of your central angle are the same. So if I have arc AC is 20 degrees, that means central angle ABC is also 20 degrees. In number 2, we're asked to find arc AC. Am I talking about major arc AC or minor arc AC? And how do you know? Abby? Good, minor arc AC because there's only 2 letters. So right now, I see central angle ABC is 110, which means minor arc AC is also 110. Next one, I want to find the arc of ABC. Well, what is arc ABC? A semicircle. How do we know? Its endpoints are what? The diameter. Its endpoints are diameter. And what did we say? A semicircle is how many degrees? 180. Okay, so now we're going to work with minor and major arcs. So here I want to find arc AC and arc ADC. I do have labeled that the central angle ABC is 10 degrees. Well, if central angle ABC is 10 degrees, that means minor arc AC is 10 degrees. And then you tell me, how would I find how many degrees the major arc is going to be. Casey? You got it. We're going to do 360 minus 10, and that will give us 350 degrees for the major arc. All right, you guys do number 5. Okay, so what should we have seen? We should have seen that the major arc ADC is 300, which means minor arc AC must be 60 degrees because a full circle is 360 degrees. And if the minor arc is 60 degrees, the central angle that intercepts that minor arc is also 60 degrees. Right. And for number 6, we want to find ADC. Well, do we agree that ADC is a semicircle? So that's 180. And then we want to find angle ABC. Well, isn't angle ABC a straight angle? Because it's a straight angle, it is also 180 degrees. All right, let's answer some questions. Was anybody still copying 5 or 6? All right, let's go on to 7. So we have circle F, which tells us F is the center of this circle. The first thing we're asked to find is angle BFC. Angle BFC is this angle right in here. Well, I'm going to guide you just a little bit. You all tell me what is AC in reference to the circle? What is AC in reference to the circle? It's a diameter. I know it's a diameter because it's a chord that's going through the center of the circle. So it's a diameter. What does a diameter do to a circle? It splits it in half, right? 180 degrees on either side of the diameter. Right. Now, what is AFC in terms of angles? What kind of angle is AFC? PJ? It's a straight angle, exactly. So it is 180 degrees. Do we agree that this straight angle is split between 35 and this angle right next to it? So in order to find angle BFC, can I just do 180 minus 35? That's what we're going to do. So we're going to do 180 minus 35, and that will give us 145 degrees. All right, next one, we want to find angle DFC. That brings us to this angle, this angle right in here. Does anybody see a relationship between angle DFC and another angle that we used to use all the time in proofs, James?
It's a vertical angle.
They're vertical angles, and what do we know about vertical angles? They are congruent, so that means this is also 35 degrees. Then we want to find the measure of arc CD. Well, the arc and its central angle are the same. Isn't angle DFC a central angle since its vertex is at the center? So if angle DFC is 35 degrees, then arc DC is also 35 degrees. All right, next thing we want to do is we want to find arc BCD. Well, what kind of arc is BCD? It is a semicircle because it's a chord going through the center. So we know that is 180 degrees. And the next thing we want to do is we want to find arc BEC. I'm going to erase this. All right, so arc B to E to C. I know this is a little blocked out here, but do we all agree that BD is a diameter? Since BD is a diameter, arc BD is 180. And now to go from arc BD to arc BC, aren't I just adding 35 more degrees? So what we're going to do for this is we're going to do 180 plus 35. And we get 115. Oh, 215, thank you. Degrees. Now we want to find arc BC. All right, so now I'm looking at it a different way. We're moving a different direction here. So this is arc BC. Well, isn't central angle BFC intercepting arc BC? So the central angle and its arc are the same, so arc BC is 145. And last but not least, we want to find arc ED. Looking at arc ED, I know it corresponds to this central angle, but I don't know that central angle. Any ideas on how we can figure this out? Ethan? Good. I hope you guys noticed this, that angle DFB, isn't that a straight angle? And these three angles together make that straight angle. So what we're going to do is we're going to add 92 plus 35, and that's going to give us 127. Then we're going to take 180 and subtract 127, and we're going to get 53 degrees. All right, I'm going to skip this independent number 8. Let's go to number 9. All right, so they're telling us circle E, which is great for us because we're identifying the center of the circle. Then they're saying C is the midpoint of arc BD. The midpoint of an arc acts the same as the midpoint of a segment. Doesn't the midpoint of a segment split it into two congruent segments? The midpoint of an arc splits it into two congruent arcs. So if C is the midpoint, that means arc BC is congruent to arc CD. Even if they don't look congruent, it doesn't matter. Then they're telling us that arc AB is 9x plus 30. Arc CD is 54 minus x. Is there anything labeled for arc BC? No. Since there's nothing labeled for arc BC and we know that it's congruent to CD, is it okay if I put 54 minus x again? Yeah. All right. I want to solve for angle AEC. I'm not concerned about that right now. I think even if you all didn't know how to find angle AEC, you'd have an intuition that you need to solve for x, at least, right? So let's start there. Let's solve for x. How would I possibly solve for x here? PJ. You got it. Right now, isn't this whole thing AD? Isn't that a semicircle? And a semicircle adds up, is 180 degrees. So we're going to say 9x plus 30 plus 54 minus x plus another 54 minus x equals 180. Could you all solve that and tell me what you get? PJ? Yep, x equals 6. All right, so now what I'm going to do is I'm going to take that 6 and I'm going to plug back in. So we have 9 times 6 is 54, plus 30 is 84, and then 54 minus 6 is 48, and then another 48. Now we want to find angle AEC. Let me see, AEC, that's this angle right here. Well, do we agree that AEB is a central angle? And if AEB is a central angle, it has to be the same as its arc, which is 84. Do we also agree that BEC is a central angle? And if it's a central angle, that has to be the same as the arc. So this is 48. So how am I going to find angle AEC? 84 plus 48. And we're going to get 132 degrees. All right, moving on to the next part. Find the measure of an arc that is half of a circle. All right, I'm going to tell you 2 different ways we can do this. Well, we know half is half. What mathematical operation goes with the word of? Close. Everyone always says division first. Multiplication. The mathematical operation that goes with the word of is multiplication. And then a circle, isn't a circle 360 degrees? So we're saying take half of 360 degrees. Well, what is half of 360? 180. So when you're multiplying fractions, you can cross simplify. 2 goes into 360 180 times. So half of a circle is 180 degrees. Right, letter B is saying find the measure of an arc that is 1/3 of a circle. Well, isn't this going to say 1/3 times 360? So we could say 3 goes into 360 120 times. All right, so that's the method I prefer. Some other students like to do proportions, which I'm fine with. So students are saying, okay, well, 1/2 equals x over 360. That's a proportion. The only issue I see when students use proportions, they think they can cross simplify through, well, this one you can't, but they think you can cross simplify through an equal sign. Can we simplify through an equal sign? No, you could only cross simplify through multiplication. That's it, no other operation. So that's the problem with the proportion if you think you can cross simplify. But here you don't cross simplify, you cross multiply. So this would be 2x equals 360, divide by 2, x equals 180. Same answer both ways. I don't care what you do. All right, let's go to letter D. We want to do 3/4 of a circle. So I'm going to say 3/4 times 360. Because I'm multiplying, I can cross simplify. 4 goes into 360 90 times. Is my answer 90? No. 3 times 90 is 270. All right, you guys do letter E. All right, who has an answer for B? James? 160. Anybody need to see me do it? All right, and I believe this is the last part for today. All right, so find the fractional part of a circle with an arc that is the following measurement. So this time I'm giving you the degree and I'm asking you how much of the circle is this arc. So an arc of 30 degrees is how much of a circle. Well, isn't that 30 degrees out of 360? So what you're going to do is you're going to take the degrees they told you and put it over 360 and then simplify. So 0 on top, 0 on the bottom cancels. So then I'm left with 3 over 36, which is 1 over 12. So a 30-degree arc is 1/12 of the circle. All right, what about 90 degrees? Well, that's 90 degrees out of 360. So we cancel out those zeros. I have 9 over 36 reduces down to 1/4. All right, you all do letter C. Okay, so you should have done 150 over 360. The zeros cancel. That brings you down to 15 over 36. Can I simplify this more? Yeah, I can divide top and bottom by 3. And when you divide by 3, you end up with 5 over 12. And that's it for today.